Hey guys, it's Josie with Queen My Pawn, and I'm going to be talking about some data analysis questions. In my opinion, data analysis is the easiest topic to go over, even easier than tables or linear equations. Still, you must pay attention to some details. At a primate reserve, the mean age of all the male primates is 15 years. So we have a group of male primates. Average is 15. And then the mean age of all female primates is 19. Which of the following must be true about the mean age M of the combined group of male and female primates at the primate reserve? So basically, if you combine the males and females, you'll get a new average. Now, common sense would say, well, just simply add 15 and 19, and now you got two groups, divide that by 2, and ta-da, the average is 17. But we got a problem. That's assuming that there is a total, that basically both groups have equal amounts of monkeys or primates. So that might not be true. In fact, you could have, for example, one male and the average would be 15, and you could have 9 females and the average would be 19. And that would mean if you combine both groups, you get 15 plus 19 plus etc. plus 19 all over 10, because one male primate plus 9 female primates is 10 primates in total. This will not give you 17. So it's the same way the other way around. You could have 15 plus etc. plus 19 over some number, let's say 10 again. Clearly this will be closer to 15, so I'll put close to 15, and this one's going to be close to 19. But it definitely won't be more than 19, because how can you have an average age of 19.2 if no one has a higher age than 19? It's impossible. So basically, the answer has to be D, and of course it is. That's the detail that you have to remember about averages. It's the total number divided by, it's the total number of items divided by, okay, no, it's the total value of the items divided by the total number of items. The total value, in this case, will be the total amount of years divided by the total amount of primates. And then you get the answer. So the next question is loading. A researcher wanted to know if there is an association between exercise and sleep for the population of 16-year-olds in the United States. So instantly you must underline that they want to find out the association. That's all that the researcher cares about, just the association. And if you have taken statistics before, you should know that a graph could contain something like this, bunch of dots, that as you go forward on the x, y also goes up. That's a positive correlation. You might have it the other way around, something like this, where x goes up, y goes down. That's a negative correlation. And then you might not even have a correlation at all. Everything's just all over the place, like this. It's unclear whether it's better this way or that way. So let's see the rest of the question. She obtained survey responses from a random sample of 2,000 United States 16-year-olds. Probably mailed them out. and found convincing evidence of a positive association between exercise and sleep. So there you go. She found out, or he found out. Well, she, because it's she. She found out that there's a positive association. So basically, between exercise and sleep. So basically, she's done. Which of the following conclusions is well supported by the data? There's a positive association between exercise and sleep for the 16-year-olds in the United States. Honestly, I would just click this right away because that sounds reasonable. But on a test, I would only do that if you're extremely pressed for time. And you shouldn't be, because it seems easy enough. Let's see the next question. There's a positive association between exercise and sleep for 16-year-olds in the world. That's not true, because it says here, United States. So that can't be true. Or it might be true, but it might not be true. So there's some doubt there. So it can't be B. Using exercise and sleep as defined by the study, an increase in sleep is caused by an increase of exercise for 16-year-olds in the United States. So that might not be true, because correlation does not imply causation. Just because something matches with the other thing doesn't mean that something causes that other thing. Just because I drink water doesn't mean that I'll go to the restroom a lot, even though they might be correlated. Maybe I'm drinking a lot of coffee. Coffee makes you go to the bathroom. Or maybe I like to get my steps in. That's one way. I walk to the bathroom like 2,000 times. So it's unclear. And it's the same thing in D. You can't tell. So basically the answer has to be A. And that's it for the data analysis questions. Just remember basically about averages, and also in averages that the group sizes might not be the same when you're combining averages. So that'll change the average value. It'll skew it either to one group or the other. If they're the same, then clearly you just divide the same amount. You add the averages and divide by 2, but doesn't apply at the average. The group size is different. And here, correlation does not imply causation. If you know those things, you'll be good. So I hope you enjoyed that video, and make sure to subscribe, click the like button, and I'll see you on the next one.